So now what we're going to use this for is we're going to use this to express different pieces of a polynomial function. All right. So the first thing we're going to look at is increasing and decreasing. And when you think about increasing and decreasing, and decreasing, we're reading the function from left to right. So as we read this thing from left to right, if the function increases, in other words, if y increases as we're moving left to right, then the function is increasing. Okay, so as x is going up, y is also going up. And you can almost think of this as positive slope. Okay, if the function looks like it's following a positive slope, it means the function is increasing at that spot. If a function is decreasing, again, I'm going from left to right. If I go from left to right here, and the y values are going down, it means I'm decreasing. And again, you can think of this in terms of slope. If the function looks like it has something similar to a negative slope, it means that the function is decreasing. Okay? So increasing, the function is going up. Decreasing, the function is going down. Again, that's when we're reading it from left to right. The other thing we're going to look for is relative maximums and minimums. And we've looked at maximums and minimums in terms of quadratics before. Okay, our vertex was the maximum minimum, and that was actually the true maximum minimum of the entire function. But now we're looking for relative maxes and mins, which just means it's relative. It's a maximum relative to the points around it. Okay, so it's where the function goes from increasing to decreasing. All right, it means we have a high point on the function somewhere, and these are very easy to identify when we're looking at a graph. Okay. A relative minimum is when we go from decreasing to increasing. It's a low point on the graph. And again, it's minimum relative to the points around it. Okay? It might not be the lowest point on the polynomial, but it's lower than all the points on either side of it, to the left and right. Okay? So again, relative maximum, relative minimum is a relative high point and a relative low point. Okay? And you'll see those on the graph. They're pretty easy to recognize. The last thing we're going to look at is end behavior. End behavior is what the function does on each end. All right. So when you're looking at the ends of the function, you're looking at the arrows and saying, okay, as I go to the left forever, as I go to negative infinity for my x, what does my y value do? Does it go up or does it go down forever? All right. As I look to the right, to positive infinity for my x, does it go up or down forever? And again, we're looking at the arrows on each end of this thing. Okay. The arrow on the left is x going to negative infinity. We want to see what y does. The arrow on the right is x going to positive infinity, and we'll see what y does. Okay? So now we're going to do this, increasing, decreasing. I've got a graph here. And again, I'm going from left to right here. Increasing is when it's going up. So as I go left to right and I follow this thing, right here, the function is going up until we get to this point right here. All right? And then all of a sudden, the function starts going back down until I get to this point right here. And then the function starts going up again, and it keeps going up for the remainder of the function. Okay? So when I look at this, the thing I have shaded in green a little bit, that's my increasing portion. And the thing I have shaded in red, that's my decreasing portion. All right? So I just want to express these in terms of the x values. I look at the x values where it's increasing, the x values where it's decreasing. In terms of that first green piece, the x values that it's going from, it goes from over here until this point in terms of the x values. So my x values where the function is going up start at negative infinity and go all the way to negative 2. And when we look at this, neither of these is going to be included because it stops increasing in each of those, and I can never actually equal the negative infinity. Okay? But then I'm also increasing from here, from this value of x, and all the way up. So I'm increasing from a positive 3 all the way to a positive infinity. And again, I put parentheses on there, and then I put my union symbol in between. I'm just expressing the x values on which the function is increasing versus when the function is decreasing. Okay? Which x values is it going up on? Which x values is it going down on? Okay? So decreasing is the x values that this function is decreasing on, that it's going down on. And it decreases from this x value all the way up to this x value. So it starts at negative 2. It starts decreasing. And it stops decreasing once it hits the positive 3. And neither one of these is included, so I put parentheses here. And that's it. Okay? And then the relative max and min is where this thing changes. The relative maximum is right here, and the relative minimum is right here. Those are values, the maximum where it goes from increasing to decreasing. And again, it's a high point on this function. And then the relative minimum is where it goes from decreasing to increasing. So the relative maximum is this guy right here, which is the ordered pair -2, 4. And I can just express that as an ordered pair. That's my relative maximum. The relative minimum is this point over here. That's 3, -2. And I express that as an ordered pair, 3, -2. Okay? Then the last thing we're going to look at is end behavior. So if I kind of hit the reset button a little bit, I'm going to expose the ends of this thing. If I just look at the ends of this thing, over here, if I look at this end, the left of the function is when x is going to -infinity. And here's how I express that. I say as x goes to -infinity. I'm saying as I go to the left, all right, that's what x goes to -infinity means. As I go for the left, I want to know what y is doing. I want to know what f of x is doing. And so I look at this end. I say, okay, as I go to the left, which is this end right here, the arrow is pointing down, which means I'm going to go down forever, which for my y values would be a -infinity. And that's it. I look at the arrow on the end. And then to the right, I look at the other end of this thing, because again, it's end behavior, so I look at each end. If I'm looking at the right, I'm talking about positive infinity for my x. As I go to the right forever, as I go to the right, what does the function do? Well, right here, I look at this arrow. As I go to this right, the arrow is pointing up, so I go up forever. So as I go to positive infinity for my x, my f of x goes to positive infinity as well. I'm just describing what it does on each end. The left end is x going to -infinity. The right end is x going to positive infinity. And then I state what f of x is doing, what y is doing. Okay? And that's it. All right? End behavior becomes very important when we start to graph these things. And for that, we're going to start evaluating infinity. Okay? We're going to plug infinity into this equation and go from there. Okay? So if I look at something like this, again, I want to plug positive or negative infinity in here, and really it becomes a game of signs where I'm deciding whether it's going to be positive or negative. So for this one, if I want to plug in an infinity in here, really the thing that makes this tough is when we're plugging infinity into this equation, we've got two separate pieces that are going to equal infinity. Okay? I've got the infinity cubed times a -2 is going to give me a negative number, but then the plus infinity is a positive number. And so how do we relate these two things? If I have a negative infinity plus a positive infinity, what's going to happen there? And really, the thing we need to do is think about what's really happening here. I can't actually plug infinity in. So I'm just plugging in bigger and bigger and bigger numbers and getting closer and closer to infinity. And when you think about an x cubed versus an x to the first, what happens is when we plug bigger and bigger numbers in, if I plug a 1 into each of these, I would get a 1 out. If I plug a 2 into each of these, I get an 8 and a 2. If I plug a 3 into each of these, I get a 27 and a 3. And if you look, this one over here, the x cubed is getting so much bigger than the x to the first. Basically, as we keep going, as these numbers get bigger and bigger and bigger, this guy, the x to the first, essentially doesn't matter anymore because it's so small compared to the x to the third. So when I'm plugging infinity in, I'm really plugging in bigger and bigger numbers. And what happens here, as I plug in the bigger and bigger numbers, the x cubed kind of takes over and nothing else matters. Okay, so when this thing is in standard form, essentially I'm just going to look at the x cubed. I'm going to ignore everything else. I'm just going to look at the thing that has the highest exponent because that thing is getting so much bigger, so much faster that it kind of takes over and controls this thing. When I do this, if I have infinity to the third power, this piece right here, infinity to the third power is still going to be infinity. Okay? And then if I have infinity times a -2, it's really just a positive times a negative, which is a negative. So essentially, when I evaluate this thing as x goes to infinity, so I plug an infinity in for x, I get a negative infinity out for y. Okay? And then it's the same thing with the next one. I'm going to plug this in. When I plug it in, again, one piece of this matters more than the rest. Okay? The x cubed is going to kind of take over this thing as the values get smaller and smaller and smaller and head off towards negative infinity. The x cubed is going to take over, so I can kind of ignore the rest of this. All right? And what happens here is I've got a -2 times a negative infinity cubed, which is a negative. And really, it's just thinking about signs. A negative number to the third power is still a negative number. And now negative times a negative is a positive. So when I plug a negative infinity in, I get a positive infinity out. And really, what we're heading towards is expressing end behavior. This one, as x went to positive infinity, f of x became a negative infinity. As x went to negative infinity, f of x went to positive infinity. Okay? So we're trying to express end behavior here. For example, when we take a look at this next one, again, we're just evaluating this thing as x goes to negative infinity, and then as x goes to positive infinity. Okay, so I'm going to evaluate it for each of these and just see what f of x does. So now when I plug this in, again, I plug the negative infinity in. If I do a negative infinity to the 9th power, would give me a negative infinity, times this negative 32 ends up giving me a positive infinity. So as x goes to negative infinity, f of x goes to positive infinity. And then I do the same thing with the positive. When I plug a positive infinity in here to the 9th power is infinity, times a negative 32 is a negative infinity. So as x goes to positive infinity, f of x goes to negative infinity. In the next one, once again, I ignore everything except the thing that has the highest exponent, so I ignore that 6x, and I just plug it into this first thing. So I evaluate as x goes to negative infinity, then as x goes to positive infinity. If I plug a negative infinity in here, right here, negative infinity squared is a positive infinity, and then times this negative 3 is going to give me a negative infinity. And then I do the same thing with the positive. Positive infinity squared, I do the squared first, is a positive infinity, times a negative 3 is a negative infinity. So as x goes to positive infinity, f of x also goes to negative infinity. Okay? If I look at the next one, same deal. I look for the highest exponent term. I'm basically just going to plug it into the 8x to the 4th, because that one's becoming so big that it's going to take over everything else. All right? So I evaluate as x goes to negative infinity, and then as x goes to positive infinity. So when I plug the negative infinity in here, negative infinity to the 4th power is a positive infinity, times a positive 8 is a positive infinity. If I plug the infinity in here, infinity to the 4th power is infinity, times a positive 8 is a positive infinity. Okay? The next one is a little bit different. If we look at these first 3 examples, they're all in standard form, so I can identify the thing that has the highest exponent. But this one, I can't identify the thing with the highest exponent because it's not in standard form. If this was in standard form, this would be an x cubed function. Since it's not in standard form, I just plug it in the way it is. Okay? So when I do this one, I'm going to put my x goes to infinity, negative infinity, and x goes to positive infinity down here a little bit lower. Because I'm just going to plug this in. If I were to plug a negative infinity in here, so f of x goes to negative infinity. So I'm just plugging it in, doing the multiplication. And really, this is just a game that we're kind of playing with our signs here. We want to know if it's going to come out as positive or negative. And now I do the same thing with the positive version of this thing, which is a positive infinity. Okay? And then it's the same thing with this next one. Again, I'm just going to be plugging it in. So let me write this down here just a little bit. I've got x goes to negative infinity, and I want x going to positive infinity, and I plug each of these in. And just be careful as you plug this in. If I plug a negative infinity in here, negative infinity squared, and then times a negative infinity, times a negative infinity to the 4th. And I just have to be careful with order of operations here. Here that's going to give me a negative. Negative infinity squared is a positive. Right here, negative infinity to the 4th power is a positive infinity. And now I have a negative infinity times a negative infinity times a positive infinity, which gives me a positive infinity. Okay? If I do the same thing with the next one, I'm going to plug infinity in here instead. Which is negative infinity. Okay?